Hello, my name is Sam and welcome to another video talking about Tapforms 5 for iOS and Mac. Today I'm going to take a look at my fuel receipt intake process and how I use shortcuts to do text extraction from my receipts, put that into Tapforms, and then use a Tapform script to extract out the contents. Now I've gone ahead, I've already done a scan here. You can see this is the receipt as scanned in. You'll notice it's at an angle. I'm using Vuescan here. It's an amazing tool. It does have an auto skew feature that will attempt to detect what the region of the document is, and we can adjust that, and it'll try and figure that out. I personally often just use the manual interface so that I can line it up myself and try to get that. That went the wrong way. So that basically we can fix the alignment as soon as possible. We're gonna make that a little bigger, so we've got some space there. And the angle of this sort of tracks not too bad. Let's move it a little bit, maybe. Let's see how that looks. Okay, let's look at, I think that looks pretty bang on for what we've got here. We can zoom in as well to see what's there and see roughly how well things line up. It's not too bad. I think that's good enough. It's not going to be 100% perfect, but it's going to work. Okay, so once we've scanned our document, can I drag that up a little bit more? We'll hit save. Big check mark saved. Now here is where I use some scripting. If you look at my GitHub repository, you can see there's an auto upload script. One of the things I added to it is this bit that basically runs Apple shortcuts with a shortcut I built called extract text from image. Now let's go have a look at what that looks like. So extract text from image receives images, and it also takes PDFs and files, and it attempts to extract the text and then stop an output. Now what this is doing is take the input path, which is going to be the image I just scanned, and then the output path is going to be an OCR file, a text file. And what that looks like, let's just hit ls-lrt here, make that bigger. We can see all of the ones that I've scanned over time. What that looks like is something like this. So we've got a bunch of text extracted out. It's done an okay job. You can see that it's scanned the handwriting okay as well. It's missed the .7, but I think that may be a little weird, but it's automatically done that. And when we come back here, we can see that this is the document we created. We can see the text there, and then we've uploaded that to my CouchDB server. So step 1, scan the document. Step 2, a file system auto importer, again available on GitHub. Step 3 is shortcuts to extract the text out, and then step 4 is we land in Tapforms 5. Now here's what that looks like. You can see that the 7 here is sort of cut off, so I can understand why it didn't process it, but a little more better aligned. This is a custom layout that I use, and you can see it's got a bunch of text. Now the notes field here contains the OCR text, and I'm going to do one quick correction here, which is to put the .7 in, but apart from that, you'll see that it's extracted a good chunk of the text, including the handwritten notes. So this is my Odo reading. We've got the date and the time that went through perfectly fine, fuel receipt totals, a couple of other things. It's not completely accurate, so you can see it's chid read instead of chip read. Got our average mileage there, and average miles per gallon, and then average miles per hour. You can see that in the Bay Area we're going somewhat slow, and towards the end of the document, not as great, but we've recognized the 1112 here, the 49, and then the 631. So I have a script called OCR pass, and we'll check this out. And what it does is it uses this text field and a number of regular expressions to figure out the contents of the receipt and then input that into the field. And you can see here I've got a number of locations that are also hard-coded. So these are different places that I've traveled to over the years and been more than once at. So you can see Bayside Chevron, Great Mall, San Marcos, down in 130 Knoll Road, San Marcos Boulevard in San Diego area, Button Willow, just off the 5, and Dixon Landing, just north of Milpitas. So those locations are used to try and match what the location was for those places I go to frequently. We have a number of regular expressions here that process through a bunch of different values. So the trip regular expression is a number 0 to 9 3 times. Sometimes sometimes shortcuts recognizes that as a period, which is good. Sometimes it recognizes it as a dash, and every so often it comes back with this sort of degree symbol and then another number. Odometer regex is 1 followed by 5 numbers, and we've got a few other things here. And what happens is I take the notes field and I split it on a new line and then process each line and try to find something in there. So let's hit play on this and see what we get back. And we can see that we've gone through the document and we've matched a trip, so which is why I put that .7 in. So trip was 265.7 miles. We found what we think is an odometer reading, and that is in fact the odometer reading. We found a date. We found a time. Interestingly, that didn't work. So it thought that those were periods. So let's see if we can fix that. So on line 9, we have the time, which should be 5:53:55 p.m. But the OCR has found it as periods rather than colons. So let's try and change that up and see what the impact is. So our time regex here looks for a number from 0 to 9, followed by a colon. And so let's change that to be a colon or a period. It looks for another number, followed by a colon. So I'm going to put in a colon or a period again. And then optionally it looks for an AM PM there. So let's just rerun this one more time, see what it does without change. And we can see that it found the time. We do need to now update the script to handle that. So we found the time. So we've got, and what happens here is we go through each of the lines and we run a bunch of these filters over it. So we check to see if it's a location that we matched. In this example, it should have matched 724 North Matilda, but because it's put them on individual lines, it hasn't found it. And because the Bayside Chevron is missing the Y in this case, it hasn't matched this entry, which is what it is. You win some, you lose some. So we'll have to manually put that in, but that's not the end of the world. And the next thing is we look for a date, and in this case we found the date and it worked fine. And then we look for the time, we find that, and then we match that out, and that looks like that may actually just work out of the box. This is our trip regular expression, so this is what matches the dot there, and if we keep going, we should see gallons. So let's go look for that. Oh, this is our odometer reading, and again you can see that we've found that, and there's also a replacement here for a slash. Sometimes the 1 gets detected as a slash, so this fixes that up so that we get the detected odometer reading correctly, and you'll see here that we had the found odo. Found gallons, so let's see if we can find that next. Found gallons, so this regular expression looks for a number, 1 or 2 digits, a period, 3 numbers, and then a capital G. So if we go back up here to this, let's make this a little bigger. There we go. So our gallons regex is 0 to 9, 1 or 2 times, a period, 0 to 9, 2 or 3 times, followed by a G or a 6. Because sometimes I notice that the G gets evaluated as a 6. So that's in there as well. Roll back down to where we were. We have the cost per gallon. So let's see if we can find that. There we go. Cost per gallon, 5.299. So we found that correctly. The total price, and the total price is essentially we're looking for a $sign followed by two numbers, a period, and then 2 numbers. You'll see that this matches a couple of times. So as we loop through, we match this more than once. If we keep going, we have the miles per gallon regular expression, and you'll see here again, we're replacing the dashes with a period, because sometimes that shows up. And you'll see here 26.9 mpg, we've extracted that. You can see that this came out pretty badly, but it did manage to get 25 mph. And then my drive time at 11:12 got matched properly. Estimated remaining regex, we haven't come across that, and we haven't come across the range. So we can see we matched another trip. Now I actually have some code in here that says if it's greater than line, so let's go back to the trip match. If it's before line 10, then it's the trip reading. I also track a trip B, which looks like a trip counter, as a separate field. So we've likely detected that, and now we can go in and we can see that we're getting the values, we're setting the values, and we're storing it. So when I hit save on this and come back to our entry, we'll see that for the most part it's picked everything up. Now range is here on the receipt, but it doesn't look like it got scanned properly because it got detected as tagger 301. So we'll have to manually fix that. We'll have to fix our location, which was Bayside Chevron, and the car estimated range was 49. This should have been estimated range, but I wrote E/T, but that's okay. So car estimated range was that, but for the most part you can see that it's automatically picked up most of the text inside. Let's hit refresh for a second to rerun the script, so we can see that the location is automatically populated. That one is another bit of magic where it looks up, it uses a script to detect location for record. Let's go grab that for a second. Library. It basically uses the get record from form with key against a known records table to populate out the location automatically. So that's my end-to-end process of how I scan a receipt in. It goes through an upload process, gets OCR'd, if you will, and then how basically the script gets processed to extract all of that out. If this is interesting to you, let me know in the comment section below if you want me to put this out there. I've been tracking my fuel for a while now, so you can see fuel usage over time going all the way back to about 2014. I did have a bit of a gap in 2021 during the COVID times, and you can see how the fuel price sort of jumped in that gap where I wasn't driving as much. But it's really cool to be able to use Tapforms to not only capture this data, load it up, have this really easy side-by-side layout view that I can edit the records, and then I can do interesting stuff like visualize just how much the price of fuel has gone up or down over time. Again, if this video was interesting to you, give me a like. If you want to see more of these videos, hit subscribe. If you've got questions, hit the comment button and put it in the video below. If this is an interesting form for you, I can share an empty version of the archive in the Tapforms 5 database. The code for much of this is already on GitHub, github.com/pasamio/tftools. So you can check that out for a script to automatically upload to your own Tapforms database. And on that note, happy Tapformsing.